So here are the instructions for how to write Lewis structures for covalent compounds. And I'm going to go over these kind of quick. We are doing a molecular modeling lab where we're actually going to play with balls and sticks that represent atoms and bonds. And so we'll get a lot of practice in this, but I want you to have a clue what you're doing, especially the people who get to do this tomorrow. First step is to write a correct skeletal structure. Let's just figure out how the atoms are connected to each other. Not worrying about double bonds or anything, but just figuring out how to connect them. What it's important to understand is that hydrogen atoms are always going to be terminal atoms. That means they're on the end. Because hydrogen only has one electron, it can only make one single bond. So it has to be on the end. It cannot be between multiple other atoms. It just can't do that. The other thing that helps you is to realize that many molecules tend to be symmetrical. So if you have like SO4, and there's 4 oxygens, well, it's probably going to be the sulfur in the middle and the 4 oxygens around. We're going to tell you enough about Lewis theory to make you dangerous. Okay? We're not telling you everything in Chem 3A. And so I'm going to be very careful on exams which problems I give you because there's a lot more to this that we're just not going to get into. We're going to try to keep it simple. Step 2 is to figure out how many valence electrons does this whole molecule have. If you've got 2 carbon atoms, each of them has 4 valence electrons. So you add those up. And if you've got 6 hydrogens, you add up how many electrons were brought by the hydrogen. And you add them all up, and that's the number of dots you can put on your structure. If you have an ion, then you add 1 electron for each negative charge, subtract 1 for each positive charge. And then you're going to take those electrons, and you're going to dole them out. You're like, okay, 1 for you, and 1 for you, and 1 for you. And you're going to try to make it fair for everybody and give everybody an octet except for hydrogen, who only wants a duet. But you can't put out more electrons than there are. So you distribute the remaining electrons and you try to give octets to as many as possible. What happens if you run out? Then you're going to have to share more. And so you're going to make double or triple bonds. And you're going to do this by taking lone pairs from some of the atoms and bringing them in and creating bonding pairs. So let's do some examples. Let's write the Lewis structure for carbon monoxide. So the first thing is to figure out how are these atoms connected. Well, this is a simple molecule, so there's only 2 atoms. They have to be connected to each other, right? So we're going to have the carbon, and we're going to have the oxygen next to it. And then we have to figure out how many valence electrons. Well, how many valence electrons does carbon have? 4. And how many valence electrons does oxygen have? 6. So 4 plus 6 equals 10. That means I can put 10 dots on this structure. So first of all, I'm going to put 2 in here because I need to have a bond, right? So that's 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that going to work out? No. So we need to share more. So I'm going to take, maybe these 2 guys look really awkward over there. I'm going to take those guys and bring them in here. That makes a double bond, right? So now I need to look and see, well, is everybody happy yet? Is the oxygen happy? 2, 4, 6, 8. Oxygen is good. How about the carbon? 2, 4, 6. Nope, not happy. So then what needs to happen is oxygen needs to not be a greedy pig and needs to take these 2 electrons here and share them with carbon and be nice. So we're going to move these guys and share those also. And that makes a triple bond. Now carbon has 2, 4, 6, 8. Good. Oxygen has 2, 4, 6, 8. Yay! Now, that looks kind of messy, so, do your little scribblings and then draw it out nice. Carbon, triple bond with oxygen, and then they each have 1 lone pair. And that's how carbon monoxide is a compound. Bye-bye.